Let's talk about vectors, what they are, why they're important. Vectors come up a whole lot in physics classes, introductory physics, all the way up to graduate level physics. They're fundamental to describing the motion of things or the interaction of objects. And so let's break this down. Let's investigate what a vector truly is. So I'll start with, if we think of an example, say, you ask me how hot it is outside today, and I say, oh, it's 53 degrees Fahrenheit outside. That number gives you all the information you need to know about how warm it is or what the temperature is, how warm or cold. And this, though, it's just a number, just 53 degrees Fahrenheit has a unit, but ultimately just a number. And we say that this is a scalar. It's the terminology that we use. This is different from a vector in one very specific way, and I'll use a different example. Let's say we have someone, and we say that she walks 5 meters. Similar to the temperature example, we have a number and we have a unit, and that's sort of it. That's all the information we're given, but it gives us some idea of, okay, she just walked 5 meters, it's some distance. And so that is a scalar, but if I changed it to instead say she walked 5 meters to the right, a very specific direction. Say she walked 5 meters this way. Now, this has become a vector. Vector is very specific that it requires some information about directionality. And so the components of a vector is the magnitude of whatever thing we're talking about. In this case, the 5 meters, the number that we're talking about, or in the case of the temperature, the magnitude is 53, plus the direction that magnitude is pointing in. Those two things together is our vector. And so there can be a couple examples of what vectors are. So we just use distance here, traveling in some direction. But we can also say things like velocity. Velocity is also a vector. So when we see it, when we have a car, and we say the car drives 25 miles per hour, that on its own is a scalar, right? Just tells us a number and a unit. It doesn't say any information about what direction that's going in. But if we say 25 miles per hour north or west or to the right or to the left or up or down, some information about direction, now again we have a vector. And typically when we're talking about vectors, we use this notation, kind of what I did before, using arrows. And so in the case of our car here, we've got 25 miles per hour north, upwards direction, or we can say, something moves up and to the right. Or we can be very specific and say, show an example, something we'll talk about later, like we have, a soccer ball or something, and it's kicked in a very specific direction. It has a velocity going this way at a very specific angle. Let's say that angle is 30 degrees off in that direction, and the magnitude is 15 meters per second or something like that. We have the information about the magnitude, how much that velocity is, which is the 15 meters per second. We also have information about its directions at 30 degrees above the horizontal. And so these are just a couple examples. I mean, and this extends to things beyond just velocity. We've got also forces. So we can have like some block and we apply, force off to the right, and we say that's 10 newtons. Thing. Same idea though. We have a magnitude and a direction represented by this arrow. Arrow is going to point in the direction. And so, like I said, vectors are super important for all levels of physics, introductory up through graduate level. They just get a little bit more complex in how they're applied, but they're super important in describing how objects interact with each other. And so it's really important to understand these as a foundational piece that you can build off of. So just remember, vector, two components to a vector, magnitude, and direction. If you have any questions with this, just let me know. Put those in the comments. And yeah, I'll talk to you guys later.